Alright, here we are with section 11.2. This is very similar to the last section. Very similar to solving systems by graphing, but now we're using solving systems by substitution. This is a different method to get to the exact same answer. That's really important to understand. This is a different method to get to the exact same answer. So what I have here right now, so you want to list out your equad, you want to list out your title, and then I've got 4 equations written here, and I have a graph that we're going to use. So my question is, we're only dealing with linear equations. That's all we've even talked about yet. So if we look at these linear equations, we got to figure out which ones are linear. So this one right here is already written in y equals mx plus b form. That's good. So 1's good. Okay. 2, y squared is equal to 2x plus 4. That's not linear. Why? Because that's square. We can't have exponents. Okay, 3, x over 3, we're good so far. The x is in the numerator, no problem. Equals negative 1 over y. That y in the denominator is no good. So this is not linear. And then x is equal to 3. Nothing wrong with that. We're good there. So we have 2 functions that are linear here. Since we have 2 of them, that makes a system. Two functions makes a system. So when we were to graph these, so like we had done last time, if we were to graph this one, we have a y-intercept of negative 1, a slope of 2 over 3. That would be our line. Down 2, back 3. That would be our line. Okay? Our other line, that's number 1. So this is the color I graphed it in. Our other line I'll graph in green. Says x is equal to 3. So on this, I'm going to go on the x-axis because it's an x, and I'm going to go to the value of 3. Okay? We know that this line is either going to be vertical or horizontal. It doesn't have a slope, right? And we're not going to put it horizontal because it'd be right on the x-axis. So x is equal to 3. Okay, from the last video, you should automatically know that right there, that is a solution. So the solution is 3, 1. That is our answer. Okay, you learned that last time. This should not be new. This should not be anything. This should be a review of what you did last time. I'm going to erase the graph now. I'm going to erase this graph because we need to focus on the answer that we just got. Okay, we have two linear equations, and we got an answer. Now let's think about another way we could have solved this instead of graphing. Okay? So we know that x is equal to 3. How do we know that? Because it tells us that right there. X is equal to 3. So x equals 3. So when we see this x here, we can replace it with 3. Why? Because x equals 3. So we get y is equal to 2 over 3. Then there's this x here. We are replacing x with 3. That's what we call substitution. Minus 1. And when we continue to solve out for y, 2 over 3 times 3 over 1 minus 1. Okay? So we get 6 over 3 minus 1. 6 divided by 3 is 2, and 2 minus 1 is 1. Guess what? Our y value shows 1. Our answer shows our y value as being 1. So far we're looking good. But remember, our answer, our solution, is a coordinate point. So we found a y, but we got to figure out what the x is. Well, we actually already know the x from right here, right? So we know the x from right up there. So our solution was 3, our x was 3, our y was 1. Okay? Substitution is another way to solve and get the exact same answer as you would have gotten if you used graphing. Okay? I'm erasing all this. I'm going to do one more, and then you need to be able to do one on your own. I'm not going to show any more graphing, because you guys should know that from the previous video. And if you don't, then come into tutoring or watch the previous video again. So this one we will do y is equal to negative 2 and 3x plus 4y equals 16. All right, let's see what we get. Okay, so for this one here, we don't have to change things around right now into y-intercept form. We don't have to. You can. You're not going to hurt anything if you do, but you don't have to. So what we need to look at is it tells us y equals -2. It tells us that right there. Let's use that to our advantage. So y equals -2. Okay, well, I see a y right here. So let's plug in that -2. Okay, instead of the y. Let's get rid of a variable. I don't like variables anyways. Let's get rid of them. We get 3x plus 4 times -2 equals 16. So 3x minus 8, right? 4 times -2 equals 16. Okay, and I'm going to add 8 to both sides because now I need to solve for x. I need to figure out what's that variable that I got left. So 3x equals 24 divided by 3, and I get x is equal to 8. Is that your answer? No, not the answer. This is not your answer. That doesn't help. We need a coordinate point. Where do your graphs cross? That's not a coordinate point. That's an x value. Okay? So the answer, the final answer, needs to be an x, y coordinate pair. X is 8. We just found that. Y is -2 from right here. Okay? This is your answer. Okay? Answer. Yay. Alright. I'm going to give you guys 2 to work on your left-hand side right now. And we got to get on to the harder stuff. These are actually pretty straightforward. These should be not hard. They should be simple. Okay? We got 2 practice problems on the left-hand side. Okay? First one. Figure out what your solution is there. It is a coordinate point, not an x value, not a y value, an entire coordinate point. All right, those 2 on your left-hand side. When you're done, come back with me. All right, if you're back with me, I'm assuming you already have the answers of both these 2. That's a 6, by the way. 6. All right, I'm erasing these. We're moving on to the hard stuff. Okay, so still using the concept of substitution, but now you got to do some more math, some harder math. Okay, than what we've done. So let's do y equals 4x and 5x plus 2y equals 39. Alright, so what you want to do here is you're still using substitution. You still want to say, oh, this equation will help me plug something into the other equation. Or this equation I'm going to rearrange so I can plug something in. We're still substituting. Okay? But in this case, it's a little different. It doesn't tell us y is equal to 4. It doesn't say that. It says y is equal to 4. Oops, wrong color. Y is equal to 4x. So even though it makes it a little more complicated, we are still looking at the y's, and we're going to say we know that y equals 4x. So we're going to take that y and we're going to replace it with the 4x. Okay, so when we do that, we get 5x. That stays the same. We're not messing with it. Plus 2. Instead of y, we're getting rid of y. We want y's out of there. We're going to write 4x equals 39. Okay. Where did that 4x come from? Instead of y, I'm writing 4x because we know y equals 4x. Okay. All right, and then when we continue to solve this, 5x plus 8x equals 39. We're going to combine like terms and solve for x. 5 plus 8 is 13x equals 39. When we continue to solve this out, we divide by 13 on both sides, and we get x is equal to 3. So we've got our x value. That is not an answer. I'm going to put it again. This is not an answer. I cannot tell you how many times I get this written down as an answer. It's not an answer. We need a coordinate point. Okay? So we're going to use that x is equal to 3 and plug it back into the first equation. Okay? To figure out what y is equal to. Because y is already by itself. We know that y equals 4x, so let's take that x and plug it in. Okay, when we do that, we get y is equal to 4 times 3, which means y is equal to 12. So we have enough to get our answer now. Our answer would be 3, that's our x, comma, 12, that's our y. Okay, as our x, y coordinate pair. Alright, I'm going to give you guys one really similar to this that I'd like you to try on your own. It's starting to get a little bit more complex, okay? It's going to get even harder. So you kind of gotta get this down. If you don't get it, stop, rewatch this part, okay? Call me over, something. You got to get this part. It's going to get harder. Okay, moving on. You get one to do on the left-hand side, and then we will continue. Okay. Alright, there's your equation. Remember, you are solving these systems of equations. Please, for the love of goodness, give me an answer that is an x, y coordinate pair. Okay, that's what your answer should look like. Alright, pause it, do this on your left-hand side.